First lesson today, we're going to look at how to find the inverse of a rational function. Just like we, in every unit, find the inverse of everything. We find inverses so often. We're going to start by graphing this rational function, and then we're going to use the graph of it to then graph the inverse. So we're going to start by just graphing this regular style. Remember, regular style, we start by looking, say, does it factor at all? Nope. Okay, so then if it doesn't factor, are any factors going to cancel? No. So what does that tell me about wholes? There's none. Okay. And then what do I usually find next? The asymptote, starting with the vertical one. It's at x equals 4, right? That's the number that would make my denominator 0. And then my horizontal asymptote, remember that's based on the degree. Is the degree bigger on bottom, bigger on top, or are they the same? Same. Same means we divide our leading coefficients. So that would be at y equals 1. 1 over 1 would be 1. And then we find the x-intercept. X-intercept, remember, that's when y equals 0. So it would be 0 equals x plus 4 over x minus 4. If you multiply by the denominator, it'll cancel and you'll get 0 equals x plus 4, which means x equals negative 4. So that's going to be at negative 4, 0. And then lastly, the y-intercept, remember that's when x equals 0. So we would plug in 0 for x to get 0 plus 4 over 0 minus 4, which is negative 1. So as an ordered pair, that would be 0, negative 1. All right, let's graph it, see what it looks like. I'm going to start by graphing the two asymptotes. We have a vertical asymptote at 4. And a horizontal asymptote at positive 1. Okay. It's got 1 point at negative 4, 0. 1, 2, 3, 4. And then a y-intercept at 0, negative 1. Is that enough information to draw both branches? No. I can draw this branch. But then I will need to find an extra point to draw my other branch. Extra point. It needs to be an x that is to the right of this vertical asymptote. What x would y'all like to try? 5? Too late. I wrote down 5. 5 plus 4 would make 9 on the top. 5 minus 4 would make 1 on the bottom. So that would be a point at 5, 9. Is that going to fit on my graph? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, we can use that to graph. Good enough. Okay, so now thinking about an inverse. Okay, and let's do inverse in a different color. I'm going to do inverse in red. Okay, so for an inverse, what happens to the points on an inverse? They're backwards. Yeah, they don't change signs. They don't flip over and become reciprocals. They just become backwards. So this point that we had at negative 4, 0 on the inverse, what's it going to be at? 0, negative 4. This point that we had at 0, negative 1, the y-intercept, what's it going to be at? Negative 1, 0. The point that we had that was at 5, 9, what's it going to be at? 9, 5. Okay. Guess what happens to the vertical and horizontal asymptotes on an inverse? They swap. So instead of having a vertical asymptote at x equals 4, guess what we're going to have? A horizontal asymptote at y equals 4. And instead of having a horizontal asymptote at y equals 1, guess what the inverse is going to have? Nope, not y equals 4. It'll be a vertical asymptote at x equals 4. Or, excuse me, x equals 1. Bless you, bless you. All right, let's look at what that inverse would look like. I'm going to start by doing its asymptotes. It has a vertical asymptote at x equals 1. The graph is going to look interesting, aka messy. And it has a horizontal asymptote at y equals 4, because they basically swap. 1, 2, 3, 4. Okay, and then I have a few points that I can graph as well. I can graph 0, negative 4. 1, 2, 3, 4. I can graph negative 1, 0. And I can graph 9, 5. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Is there enough information to graph this one?
Yeah.
Yes. You'll have a point in each branch. So we'll have, if you look at right here, these two would need to follow the vertical and horizontal asymptote right here. It's really hard to do this with other graphs underneath it, but we're making it work. Okay, there it is. This one right here, it would follow the horizontal and vertical asymptotes that I did in red. Just going down this way, continuing this way. Do y'all remember inverses are technically reflections across what line? Y equals x, right. So kind of imagine if you had a line going right down the diagonal, the two sides should be reflections of each other. Actually, kind of, the bottom I did better drawing the bottom than I did the top, but wasn't that fun? Graphical representation of the inverse. Y'all ready to do them algebraically now? Okay. Algebraically, you're gonna feel like you've done this process before. You're gonna do this and be like, have I done this before? Because it's going to feel very similar when we were solving log equations that had different bases. It's going to feel very similar to the process we did for that. First step always for finding an inverse algebraically is what? Switch x and y. Swap x and y. Okay, and then the second main step is after you swap x and y, then what is your main goal? Resolving for y. Isolate y again. Good. Resolve for y. Okay. So I'm going to start by swapping my x and y. So instead of y equals, I'll have x equals. Instead of x plus 5 on the top, I'll have y plus 5. And then instead of having x minus 2 on the bottom, I'll have y minus 2. So the problem, what happens is when we swap the x and y, it creates two y's. Can I just cancel them? Can I just bleep, bleep, cancel them out? No, that would be silly and pointless because then you wouldn't even have a y to resolve for. What do you think we should do next? Multiply by the denominator. Cancel denominator. By multiplying by y minus 2 on both sides. Very good. Alright, that's going to clean up the right side. What am I going to do on the left side though? Distribute. Very good. Okay, so on the left side, I need to take that x and distribute it into the parentheses. So I'll have x times y first, which is xy. And then I'll have x times negative 2, which is minus 2x. Or excuse me, minus 2x. I wrote y even though I said x. Is this process feeling familiar to anyone? Okay, well, we've done it before. So we got rid of the fraction, but unfortunately, we still have two y's, and we need just one y equals 0. Or it's not y equals 0, but one y equals. Anyone have an idea of what we would do next, if you do remember this process? No? No. We already distributed. No. What? Isolate the y's on one side. We want to get the y's on one side, and the non-y's on the other side. Good job. Get y's on the one side and everything else on the other side. Okay, so to do that, do y'all want to get the y's on the left or the y's on the right? It doesn't matter. You want the y's We're going left. So I'm going to do minus y. Minus y. I'm going to cancel this minus 2x by adding 2x and adding 2x. Let's clean that up. So these will cancel and these will cancel. On the left side, what am I going to have now? No. xy minus y. And on the right side? 2x plus 5 or 5 plus 2x, however you want to write it. Okay, looking good. Then what? Take out the y. Factor out the y. Factor out the y. Okay, so instead of having xy minus y, we're going to take a y out front. So if I divide both of these by y, what's going to be left over? X minus 1. Good. Nothing changed on the right. It's looking great. Now, one more step to get the y by itself. I keep trying to make it a y. Thanks, Mason. I made that mistake earlier. Yes, divide by the whole parenthesis of x minus 1. Divide by the parenthesis. So on the left side, what happens to the whole parenthesis? It goes away. And we're left with our y equals 2x plus 5 over x minus 1. How do we notate that this is the inverse? Yes, you put that little -1 notation on it, which just means inverse. Y inverse. Amber alert? I know, they need to find a hobby. Alright, just a note, the inverse of a rational function is what type of function? Still a rational function, which is different than every other inverse we've ever done. The inverse of a, actually no, it was the same for linear. Linear's inverse is still a linear function, but quadratic inverses are square root functions. Cubic inverses are cube root functions. Exponential inverses were what type of functions? Logarithmic, good. But rational functions inverse are still rational functions, and you could kind of see that when we graphed it. I mean, the first one was rational, the second one was rational. So it should still be rational. If you end up with like a 2x squared plus 5 for your answer, that means you probably did it wrong. All right, let's do a couple more so we can get that practice in. I'm going to not write the steps on this one. Let's see if we can just remember the steps. Okay, step 1, swap, good. So become x equals 3y minus 4 over 4y minus 3. And then? Multiply by that denominator to cancel it. So we get 3y minus 4 on the right, but on the left, what are we going to need to do? Distribute, right. So that gives me 4xy minus 3x. Excellent. Yeah, you want your y's to be on one side, so these terms need to be on one side. The terms that are not y's need to be on the other side. And then add 3x. Good. So these cancel and these cancel. So on the left side, I'm going to have 4xy minus 3y. I know. And then? Factor it out. Factor out a y like a little GCF. So if you divided both of these by y, you'd have a 4x minus a 3. Okay, and then what would be my last step? Divide by that parenthesis. And now you might see why Danny said, oh wait, you did this on purpose. It's the same. The inverse of 3x minus 4 over 4x minus 3 is 3x minus 4 over 4x minus 3. That must mean that it's like perfectly symmetrical about y equals x in order to get it to like perfectly match up to be itself again.
We did all that work for what?
You didn't know it was going to be that. Was it that on the last one? Yeah. Was it like that on the last one? Was it the same as the original? No, so that's not always going to happen. Alright, one more. Yep, we're going to swap our x and y. And then multiply. Good job, Honor. Dang, you got these steps down. What's funny is when we had these same steps on the log equations, people were not good at it then. But look at us now, killing it. Why is it not hard now? They're brand new. Okay. Then what? Yep, get your y's on one side. Alright, cleaning it up. Let's see, these and these are gone. We'll have xy minus y over negative 1 minus 4x or negative 4x minus 1, same thing. And then what?
And then
Factor out a y, like a little GCF, right? X minus 1. And then my last step here, then you divide it by that parenthesis at x minus 1. Alright, let's talk about what the most common mistake is. Most common mistake. I've got this beautiful little answer here. That is my beautiful answer. Guess what people most common mistake on these do? They try and do more. They try and cancel these x's, cancel these ones, and they write their answer as negative 4. Where at, babe? At the y. Oh, yes, thank you. Thanks.
would you also write it as
You could, yeah. You could say f inverse of x like that. Function notation.